Let's make sure the volume's on. Oh, look, it is. Let's turn it all the way up so the internet can hear me, even all the way in Iran. There we go. There we go. Okay, so limit of theta goes to 0 of 1 minus cosine squared theta over theta. You know that's sine squared theta. Now, I'm going to make a mistake here. I'm going to say this is totally equal to 1. And notice I write it in red. Notice even you and I ran. I'm going to write it in red because it's wrong. Okay. Yep, just a second. I'm still writing. Okay, so I can just split that up into 2 of those, right? Why not? Volunteer. Why can't I just split it into sine theta over theta times sine theta over theta? Yes, Noah. The denominator is not squared, so I only get one of them. So I can split it up, but only one of them. Thank you. So I could do sine theta over theta times sine of theta. But only one of them gets over theta. Only one of them gets it. Now, we've already said the limit of this is what? The limit of this is 1. But the limit of this, where's sine theta going as theta goes to 0? 0. So what's this getting close to? 0, sad panda. Now, the mistake that most people make is this one right here. They just, oh, it's 2 of those. No, but then the denominator is theta times theta, which is theta squared, and you don't have that. But that's a good one. That's why 31 is a great question to ask. 29 is also a good one to ask because we end up having some fun with some trig identities. We got the limit as theta goes to 0. What do we got? 5 over theta times cosecant of theta. Cosecant is 1 over the what? Sine. So the limit as theta goes to 0. 5 over theta times 1 over sine theta. Copy dot reciprocal that puppy, so we get the limit as theta goes to 0 of 5 sine theta over theta. Sorry about that. All right, now we can break it up. What can we do with this 5? Yes, it's a bad breakup. It even goes outside of the limit. What's the limit of that puppy?
0.
No.
Multiply by 5, guys.
The limit of that is 1, not 0. If it was 0, it wouldn't be so interesting. But it's interesting, so it's not 0. It's 5 times 1, which is 5. Yes. Yay. Stop and check out. Questions on that? Stop and check out. Questions on that? All right. Then let's go to the AP questions. AP 7. I don't remember what that one was. Yes. Yes. This is a train wreck. This is a train wreck because just the temptation on this one. Number 7, we've got the limit as x goes to pi over 3. Yeah. Of sine of x minus pi over 3 over x minus pi over 3. Now you're really tempted to say, well, that's 0. No. Oh, ideas. What should we do? Yes, Jared.
Use a substitution like u equals x minus pi over 3.
Yeah, let u equal x minus pi over 3. Okay, so then that becomes, okay, now you have to be careful. You have to substitute this how many times? 3. 1, 2 are the easy 2, but you also got to say, well, what's this going to? So we've got the limit as u goes to something. I'll talk about that in a second. You sine u over u. It'd be really nice if this was what? So if x is getting close to pi over 3, what's pi over 3 minus pi over 3 getting infinitely close to? 0. So what's u getting close to? 0. Yay. What's that limit then? 1. But it's a multiple choice problem, so the answer is C like kitty cat. Okay, questions on that one? Then another beautiful one. Let's go to 8, because I don't even see how to do 8 off the top of my head. Let's look at that one. We got the limit as x approaches 0 of no. What is this train wreck? No, not even that. Worse. 3 sine squared x. Ugh. Ideas. But then you recognize, wait a minute. Just a second ago, I took 1 minus cosine squared and I replaced it with what? Sine squared. Could I also do that here, but the other way around? Why would I want to do that, though?
So then you can
Yeah, you factor out 1 minus cosine squared is the difference of what? Yes, but I have a feeling like something really awesome is going to happen, Christina. It's going to be 2.
No, difference of 2.
Difference of 2 squares, right? So if we replace sine squared with 1 minus cosine squared. So first off, let's use the properties of limits here. Let's clean some stuff up. I'm going to take this 3, move it on out. But if I move it out, it's in the what? So it's really moving out 1/3, right? So I'm going to replace this equal to the limit. Okay, now here's the good news. Here's the good news. If you plug in 0, what happens to the bottom? Cosine when x gets really close to 0, what's cosine getting really close to? 1. What's 1 minus 1? 0. Is that good news or bad news?
Bad.
Possibly, because we don't care with the limit what happens at 0. We just care what happens as we get infinitely close. So it's possible it may be some sort of removable discontinuity. Otherwise, it's going to be a vertical asymptote, and that's what we're going to talk about today. It is possible that algebra will save us on this one. Now, some of you said that this is equal to, and notice how I have to keep the limit in. So this is 1 minus cosine x. Now it's the difference of squares downstairs, so you can pretend it's like x or 1 minus x squared. That's 1 minus cosine x times 1 plus cosine x. And oh, holla math, what cancels? Yeah, 1 minus cosine squared. Now, here's where kids smoke cocaine, though. What's left on the top when I cancel everything out? People do. Okay, because I'm not going to lie to you. Some of you just be like, oh, sweet, that's equal to 1 plus cosine x. No, that's in the what? Denominator. What's left on the top? 1. I know, Brittany, it's hard to imagine this, but you grade papers and you're like, you canceled out everything in the top, so you just brought the bottom upstairs. No, I know. Well, that's the most rational explanation I have for some things.
You didn't give enough homework.
Exactly. Okay, now cosine's getting really close to what? No. Cosine's getting really close to what? 1. 1 plus 1 is 2, so you've got 1/3 times 1/2, which gives you 1/6. And hopefully that's one of the answers. Yes, it is A like apple. Okay, Justin. Justin, I need to beat something out of you. Those of you that have had me in class before probably remember the first moment I said this.
We'll close our eyes while you beat it.
We never make fun of students who do more than the teacher assigns. Ever. So you do more than I assign, that's wonderful. Naturally curious, you just looked at that problem and it looked good. We never make fun of students who do more than the teacher assigns. It's the last rebellion really left for teenagers. Like teenagers, they go home and they're like, oh, I don't like my parents, I'm going to run away. Oh yeah, kids have been doing that as long as they've been parents. Or I'm not going to, like instead of being an engineer, I'm simply going to be some loser job. Like, I'm going to work at Burger King. Your parents are like, yeah, I did that in the 60s. Everybody's done that. The only way you can rebel against your parents and really make them think they've screwed up is if you go home tonight and you're like, hey mom, guess what? I'm going to stick it to you. Beckman assigned 1 through 60 odd. I did 1 through 60 all. Like your parents are gonna be like, whoa, what did I do? What did I do? And then you're like, yeah, how you feel now? Bazinga, how you feel now? Bazinga. Yeah, your parents are gonna start crying. They're gonna be like, I've screwed up. Where did I go wrong? And you're gonna be like, Beckman was right. That is the only rebellion left. Like everything else, somebody's already done that. So doing more than the teacher assigns. Noah.
I need to be really trained.
Yeah, it's the real number 8. So suppose.
Yeah, okay.
Well, I saw AP, and for some reason, I just really wanted to do that AP problem. As you can probably figure out, I really like the AP problems. Okay, suppose negative x squared plus 1 is between g of x and secant of x. For all x, what's the limit? All right, well, secant x is 1 over the what? 1 over the cosine. What's cosine getting close to as x gets close to 0? 1. So this is getting close to what?
1.
And this is getting close to what? 1. So here's what we say. Because the limit as x approaches 0 of negative x squared, and notice I put it in parentheses just so there's no doubt, even though there really shouldn't be any doubt. So this applies. Now we got to see, does it apply for the limit too? So we have to put the limit in there. And notice again, I'm using that really precise. Yes, I know it involves a lot of writing, but what's this limit equal to?
1.
So it's being squeezed or sandwiched. And what's this going to?
1.
because it's between 1 and 1, 3 dots, it means therefore by sandwich theorem or squeeze theorem, we'll take that too, theorem, the limit as g approaches 0 of g of x is equal to 1, smiley face. Oops.
Whoa.
Way off.
Seriously.
Way off. All right, Simon, check out. Questions on that one?
Limit your set.
It looks
Well,
like
it's
rather
like
than
the
g of x, it
the
looks like
limit of
6.
sex.
The brain sees what it wants to. I would like it noted for the record that's on the internet now. Good thing I went through homework questions.
Don't worry, the internet.
All right, other ones you're dying to go through? It's kind of the ones that got a lot of questions.
I'm gonna watch
69?
the videos.
Let's look at 69.
25. What?
69. Didn't we just do it?
Nick, I'm glad your aspirations are altruistic. If I didn't know you better. Okay, f of x is equal to 1 if it's rational. 0 if x is irrational. And then they ask us, guys, to use the squeeze theorem to show that the limit as x approaches 0 of x times f of x is equal to 0. Okay, real quick, let's think about this one. It's either 1 or it's 0. That feels a lot like when we were doing which kind of squeeze theorem problems. That feels like it's between 1 and 0. It's either going to be 1 or 0, 1 or 0, 1 or 0. It feels like a cosine one, or it feels like a sine one, right? Because there's going to be a best value and a worst value. A best value and a worst value. So this is either going to multiply x by what? Or 0. But we only care as it gets really close to 0. So we're going to have two ends. At the lower end, it's going to be multiplying by what? X by what? What's the lower end? 0, right. And on the higher end, it's going to be, right. So we can squeeze this between the limit as x approaches 0 of x times 0. Can you still see? On the higher end, we're going to be multiplying by what? 1. But here's the good news. We don't really care because what's the limit of that? 0. What's the limit of that? So it's stuck between what? So because it's stuck between 0 and 0, it has to also be, yep. So therefore, again, therefore by the sandwich or squeeze, whichever one you want to call it. Because you're sandwiching it between the top and a bottom limit. Yep. There you go. All right, you want good news or bad news? Bad news, there's no daily quiz today. I know. Which means good news, we can get smarter right away. Yay, take out your notes. Infinity. Sometimes I don't have enough time, and I took too much time to do questions today. 1.5, limits at infinity.
I like how we already have an irate.
Nah, I don't know who it is. Don't. I'll grade it at the end of the period, James. Oh, actually, I take it back. Henry, take your homework, pass it back to Henry. I forgot I got a TA this period. Take your homework, pass it back to Henry. Make sure your name is on it somewhere. Today, limits at infinity goal. We are going to be able to use limits to discuss A, rationals.
I get the whale from Blackjack. No. Blackjack.
Beautiful.
What is that?
Use limits. Shh. It's American people. Use limits to discuss A, rationals, B, asymptotes. Oh, C was vertical and horizontal. Okay. Thank you. Shh. Remember when my class didn't talk nonstop?
Sorry.
Okay.
Oh, the Iranian stuff.
That's it? That's as pretty as you can make it?
Yes, sir.
Okay. 1.4 homework.
I'm not. Oh, you want me to actually put it in?
Yeah.
Should
You don't
I
have to do a
just
daily
check?
quiz today.
Should I just check? Should I just hit
No,
checks?
no. You grade it out of 5.
I
This,
have to grade it?
yeah. Henry, here's what you do. You look at the ones they did. If they did almost all of them, 5 out of 5. If they did more than half, Henry, they should write the numbers at the top or find somebody who does. Because here's what you have to do. You have to write at the top the numbers they didn't do, so when they turn in all their homework at the end of the chapter, that's all you have to look for instead of doing the whole thing. So all of it, almost all of it, 5 out of 5, most of it 4, half 3, less than half 2, barely anything 1. But don't grade it twice. Grade it once, then just look for it the second time. All right, so all of this should seem familiar because this is really pre-calc-ish. Pre-calc-ish. In fact, if you have me for Algebra 2, we actually talked about this in both Algebra 2 and Honors FST. But now we're going to use the calc terms to define it instead of just saying, oh, it's where X can't be.
The dotted lines.
Yeah, instead of using that as our rigorous definition, we'll have a better definition for it today. So first thing we're going to talk about is limits at infinity. Limits as x goes to infinity. I've told you for a very long time that we know very few limits. We know sines, cosines. We know the limit of a constant. We know the limit of a linear. We are going to add to that today. This will be the 5th thing we know the limit of. The limit as x goes to infinity of 1 over x. All right, so here's the dealio. You've got one pizza. You're cutting it into x slices. As x grows without bound, how much pizza is everybody getting?
One less.
Talk to the person standing next to you.
Well, how many people are eating it?
One pizza.
Yeah.
We're cutting it into x slices, and x is going to infinity. Everybody gets one slice. The amount everybody's getting is going to what? Talk to the person standing next to you. Or to yourself.
I'd be like, hey, everybody's eating a molecule.
But then what are we doing to that molecule? Splitting it. And then what are we doing to those electrons? Using an insane amount of energy to split them. And then what are we doing with those split electrons? Using an insane amount of energy. Right, volunteer, what's it going to? Volunteer, 0, right. Why? Because the amount that you're getting is decreasing. Because you're cutting it into an infinite number of slices. In other words, the amount's growing without bound that you have to cut it into. How much is everybody getting? It's getting close to 0. Now, question, will it ever get there? No, we'll never get to 0. But, guys, shh. We'll never get to 0. But if however small you wanted it to be, we could get there. Like if you wanted a molecule, we could just figure out how many times we have to cut it to get it down to the molecule. We wanted to get it down to electrons, half an electron, third of an electron. Yes, we could. The amount that we could have could decrease down to any amount that we have. So the limit of 1 over x as x goes to infinity is equal to 0. Also a question. The limit as x goes to negative infinity of 1 over x. This is harder for a real life example, but now instead we go to negative infinity instead of positive infinity. Where is that going to? Now we're plugging in giant numbers, but they're negative. What's it still getting close to? 0. If you remember, 1 over x squared looks like this. 1 over x squared looks like this. On both ends, it's going to 0. One goes above the graph and goes to 0. One goes below the graph and goes to 0. Both of them head to infinity, though. Excuse me. Both of them head to 0. Both of them head to 0. Because we have that later today, we're going to define that as a horizontal asymptote. But for right now, we're just finding the limit as it goes to infinity. One more for you, the limit as x goes to infinity of x. What's that going to be equal to? Yeah, I hate to even put the equal sign in there. It's going towards infinity. Your book uses the equal sign. I hate to use that because that implies that you can get infinitely close to infinity, and you can't. So I'm going to put the arrow goes to infinity, but be aware that they will say equals as it goes. And number 8, the limit as x goes to negative infinity of x is going to approach what? Negative infinity. Okay, now that we know that, we're going to talk about rationals, which takes us back to the glory days of pre-calc. Now, I will warn you, people who took this class last year will attempt to tell you some mnemonic that works for this. I'm telling you, you can't use that. Why? Because it won't, number one, anybody that you tell that to won't know what you're talking about because it's so specific to like that woman who taught this last year's curriculum. And number two, once you learn the Hopi Tals, Your reason to know that has already disappeared. So for rationals, what are we going to do? I'm going to teach you two different ways to do this. There's a free response way and there's a multiple choice way. And it boils down to that key question of calculus. What really matters? In college, pizza. Yes, pizza is very important.
It's so expensive. It's like,
Yeah, but here's the good news. When you move to a college town, there will be a Little Caesars or something even cheaper than Little Caesars that will make you question that. Papa Murphy's is not cheaper than Little Caesars.
okay, Papa Murphy's is good.
By the way, has anybody went to Walters 303 down the road?
Yeah,
Dude, there was
Yeah.
something so long.
That is pizza. That is pizza.
When you're
So many people
stoned up
walk
and
work.
that's the good stuff.
When you're what?
When you're stoned up and like that's the good stuff.
Stoned off end?
But I mean, I'm just theorizing. Like I'm guessing that it's probably really good when you're stoned.
Mr. King, this is what I was talking about.
Sorry,
Not enough math homework. It's not our fault. It's not about the
Noah, I really hope you're just talking anecdotally,
I
not
will-
based off personal experience. Okay, so the first way is the long way, of course. That's the free response way.
Who's that?
Hi, Mr. King. You were watching. What a coincidence. Free response way. This is the long way you have to show your work. So let's take a look. The limit as x goes to, let's go to infinity. Why not? Of 3x squared plus 7x plus 4 over 4x to the third plus 3x minus 7. Okay, so we're going to go to infinity. We've got a fraction. We've got a top and a bottom. Now, the good news is a rational is a polynomial on top, a polynomial on bottom, remembering back to the glory days of pre-calc. Okay, question to you. What really matters in this problem? Like, what's going to determine it? I'm going to need to, hold on. I need to spend about 5 seconds thinking, then about 5 seconds talking to your neighbor. What really, thinking, not talking. What really matters? What really matters? No. What really matters? Okay, talk to the person next to you real quick. What, or somebody around you. What really matters?
Either the degree of continuous or the
What really matters?
You know what really matters?
All right, volunteer. What really matters?
Oh,
Noah.
I know what it is.
I think it's the leading exponent,
The leading exponent. Like, are you talking about the 4 or the 3?
not the coefficient.
Not the coefficient? Okay. Here's what you have to understand in calculus. What really matters. And notice, I'm saying this, but I'm not writing it down. But if it helps you understand it, write it down. Just like Breebach, I say a lot more than I write down. I know some teachers like what they say is what they write down. And then you're like, why do you write it down when you just say it? I can read. What really matters on this one is we're plugging in infinity. Talk about infinity. That's a number that's really what? Like a trillion? No, way bigger than a trillion. So much bigger than a trillion that you couldn't even see a trillion in your rear view mirror. If you plugged in a trillion and you cubed it, how small would just a trillion be? So you took a trillion and multiplied it by a trillion and then multiplied that answer by a trillion.
That'd be a big number.
How much bigger is that than just a trillion?
Like a
A lot. How much bigger is that than a trillion squared? A lot, yeah. The only thing that matters in this is what is the degree of the top and what's the degree of the bottom. If you remember, you took me in pre-calc. We talked about the pre-calc way to do this, where I just told you this, but now we're in calc and we can actually determine why is that the only thing that matters. You must use algebra to show this. You must use algebra to show this. You cannot just use intuition. So here's what you got to do. What is the biggest exponent that's either on the top or the bottom? 3. So here's what we're going to do. We're going to multiply the top and the bottom by 1 over x cubed. Now, I am aware that if you go to somebody in my BC class, they're going to be, oh, boba. No, no, no. First off, no college prof knows what that means. Nobody. Like, if you walk in and you tell them all these rigorous definitions, then you go boba, they're going to be like, who's boba? They're like, no, no, no. It's the opposite of Betsy. And they're like, is that your girlfriend? Like, no. Nobody knows what you're talking about. There's no rigor to that definition. And number 2, after we learn the Hoping tiles, there's no reason to learn that. You must show it this way. I will not let you use the shortcuts that they just memorized last year. I will not let you do that. I'm going to teach you rigorous calculus. You're going to do great in Calc 2, but I'm not going to just teach you shortcuts, because you can really easily turn Calc into just memorizing. And then somebody asks you like, oh, what's the limit mean? And you're like, boba. And they're like, what's that stand for? Bigger on top than on bottom. And they're like, that's what you learned in calc, huh? Because I learned that in algebra 2. Yes, we're going to learn the calculus way. We're not going to learn the shortcut way. So I'm going to let you know there have been some students who have been corrupted on this. I will not let you be corrupted. So we're going to multiply that through. Now, here's what we get. Now, somebody mentioned in third period, why are you showing all this work? Because I'm teaching you. If I was doing this problem, I wouldn't show all this work, but I'm teaching you how to do it. So I have to distribute that to everything on top. So I get 3x squared over x cubed plus 7x over x squared. Nope, 7x squared over x cubed plus 4 over x cubed. All over. I know, but I'm teaching you. I'm not telling you. Because you all know you've had that teacher that like, oh, it's so obvious. And then you're like, no, it's not. Okay, so notice I distribute the 1 over x cubed to everything. Now I can do some simplification. Thank you. There's no square there. Thank you. There's no square there. Okay, so the x squared over the x cubed, that simplifies to just what? Right? Have I done any calculus yet? No, I'm just doing algebra. Just doing algebra. I could have really showed you this in algebra 2, but I would have blown your minds away by making this harder than it needed to be at algebra 2. Now that we're in calculus, we're doing it the calculus way, which involves using limit. So 3 over x, that just gives me 3 over x, plus those cancel to just give me 7 over x squared. Those cancel to give me 4 over x cubed. Those cancel to just give me a 4. Those cancel to give me a, what's that going to be, 3 over x squared? And those cancel to give me a 7 over x cubed. Okay, have I done any calculus yet? No, 100% algebra. 100% algebra. Now, question, why did I do that? Why did I do that? I need you to think about that for just a second. Why did I do that? Or I'm totally screwing with your heads and I just messed up and I have no idea what I'm talking about. I need you to think about it for a second. Why did I just do that?
Was it to ask?
Think! Okay, let's go back to a rigorous definition. Thinking means engaging your brain to go through a process. There's nothing that involves your mouth in thinking. That's a separate, totally different process. Okay, volunteer. Burns, what do you think?
Is it the, when you had the asymptotes and you had to like change the?
Nope.
Okay, never mind.
Where are we taking this to? Not x equals 0, x goes to 0. We're taking it as x goes to infinity. Right. Infinity can't have a vertical asymptote. Why did I do this? Brittany, are you wanting to answer?
No, I have to sneeze.
Okay. Anybody else? Why did I do this?
Sorry.
Or be honest, I have no idea why you did this. Like, please tell me. Yep, Noah.
I was raising my hand.
Oh, okay. Like, I have no idea. Question. What's the only thing we really know the limit of at infinity? We know it for x, and we know it for 1 over x. Good news. Everything that's got an x in the denominator, as x goes to infinity, x grows without bound, all of those are going to go to what? 0. So here's the deal. What's the top going to be? 0 plus 0 plus. What's the bottom going to be?
4 plus 0.
Okay. Now here's the crazy part. Notice there's no more what? Yeah, there's no more x's. Oops, excuse me. I just took the limit. No, don't write that because I took the limit. So I'm going to have 0 plus 0 plus 0. Yep, over 4 plus 0 plus 0. What's that going to go to? 0. What's the limit as x goes to infinity of this one? As x grows without bound, this will get closer and closer and closer to 0. Now, why is that? Because there's a bigger degree on the bottom than there is on the top. But why does that work out? Because if you multiply everything by 1 over the largest degree, 1 over the largest degree, everything else goes away. And we can see what's happening as x goes to infinity. Basically, this is just going to go to infinity. This is going to go to 4 times infinity. Turns out that's going to get really close to 0. So this is the free response way when you have to show your work. Because here's why you can actually take the limit. Here's why you can actually take the limit. Now, I'm going to show you a shortcut for multiple choice because we don't have to show our work on that one, and there's a shorter way to do this. But again, it answers the question, what really matters? If I don't teach you anything else that gets you ready for Calc 2, I got to teach you what matters. Because in Calc 2, we have to decide. And that on my own end, when I taught BC last year, I did not make them give up Boba Betsy. So they never really learned to look at a function and determine what matters. They just had used their rules to memorize it. And unfortunately, when we went to series and sequences, and all that matters is you determining the question, what matters in this? They've never done it before, and I had to blow their brains away. And unfortunately, it was April, and they didn't have much left. Yep.
So if the degree was in the numerator,
yep.
Would you just multiply?
Let's see what happens with that. Let's do another example. Example 2. Let's do one where the degree of the top is bigger. Let's go for how nasty do you want it? Let's make it really nasty. 7x to the 16th
Oh, God.
plus 4x squared plus 7 over 6x squared plus 3x plus 2. No, really. Okay, people. Again, going back to what really matters. Does it matter how big that is? No. Does it matter if it's to the 16th or to the 4th? No, because the 4th is so much bigger than the squared that the squared doesn't matter. It goes away. Okay, on your marks, get set, math. On your marks, get set, math. Undefined? Hmm. You best show the work for it.
Got 40 now.
49. Okay. Do you want the answer to the next one to be 49? Okay. Yeah, what's up?
You want me to pass it back?
Yeah, give me just a second to go through this one. All right, volunteers, what do I do? What do I do? Yes, by close. 1 over x to the 16th. Right, multiply both by 1 over x to the 16th. Let me ask you a question, though. What's really the only thing that matters on the top?
7x.
What's really the only thing that matters on the bottom? Okay, why are we showing this? Because it's for your response. We got to show our process of how we got this answer. If it was a multiple choice, all we're going to do is really look at the biggest degree on the top, the biggest degree on the bottom, and just divide by that. We're even going to use an approximation sign, which means it's really closely approximated by. As you plug in a trillion, this is so much bigger than this. This doesn't even matter. You're not even concerned with where that is. This is so much bigger than this. You don't even care where that is. It's so much bigger. A trillion squared is so much bigger than a trillion. Doesn't matter. But for your response, we got to show the work. So limit as x goes to infinity. Notice I'm going to skip a step here. So I'm going to 7x to the 16th over x to the 16th is just 7. 4x squared 14th plus what's there? 7 over x to the 16th, right on. Divided in the denominator, that's going to be 6 over x to the 14th plus 3 over x to the 15th plus 2 over x to the 16th. All right, as you take the limit, what's this going to go to?
7, 0, 0,
Yep.
0, 0.
So 7 over 0, which is what? Undefined. Now question, is it going to positive infinity or negative infinity? Positive infinity, right, because this would grow, this would be going to 7, this would be getting infinitely small. 7 divided by something getting infinitely small is going to what? Infinity. And basically you have to know, like, is it going to positive infinity or negative infinity? Now, if that was a negative 7, where would it be going to? Negative infinity, but 7 over something that's decreasing without bound is going towards infinity, which is what the graph would look like as x gets big, y is going to infinity. That's, remember, from the glory days of pre-calc. Yeah. Notice I put arrows to infinity. I don't like putting equals to infinity. Infinity is a journey. It's not a destination. We can't be equal to it. We can be going to it, but we can't be equal to it. Yep.
If you had a smaller exponent on the top and the bottom.
Yep.
Would you use the same method? as math
Absolutely,
to
yep.
solve that?
It doesn't matter where the largest exponent is. That's the same method that we use. In fact, if you looked at the previous example, the bottom was bigger than the top. No,
And so does this work on all rational polynomials?
Yep.
You know-
all rationals have a polynomial on top, a polynomial on bottom.
Okay.
That's the definition of rational, a polynomial divided by a polynomial. Now, this is the free response method. I'm also going to show you the multiple choice method. Why? Because we don't have to show all our work. You have to show all our work, and that's how you do it. If you don't show all your work, wave, don't show all our work. So the multiple choice method. Would you want it to work out to again?
49.
Okay, we'll take the limit as x goes to, let's go to negative infinity. We just haven't done a negative infinity one. Negative infinity, so what are we going to go to here? We're going to go to, yes, I can. Thank you. What should we go to? 49x squared plus 7x plus 3 over, I don't know, x squared plus 3x plus 4. Okay, multiple choice method. We ask ourselves the question, what matters? Well, what's going to determine the behavior of this as we plug in giant negative numbers on the top? Yeah, 49x squared. So we're going to even put, notice I'm putting the approximated sign. It's not equal to this. It's not. But it so well determines what's going on, it doesn't matter how far they are apart. So notice I put the wavy signs because it's no longer exact. The top is 49x squared. What's going to determine the behavior of the bottom? What cancels out in that? X squared. What's the limit as x goes to negative infinity of 49? 49. That's the multiple choice method. So notice, I'm not exactly solving it, but I am saying as x goes to infinity, what's the only thing that matters? On top, it's just the largest exponent of the coefficient in front of it. What's on bottom? The largest exponent of the coefficient in front of it. Those are the only thing that matters. So it's so closely approximated, it doesn't matter what the other things are doing. A trillion is so big that a trillion squared is so much bigger than a trillion, it doesn't make any difference. But here's the deal. Infinity is so much bigger than a trillion that we can use even more defining properties of that. Christina.
They made it about equal to because the other two don't matter.
Yep. Because this is going to be so much bigger than this that this will be the dominating factor. This will be the dominating factor. Like, okay, pretend two football teams are playing. And our varsity squad is 49 times better than their varsity squad. Does it matter how much better our JV is? No, because our varsity is going to be up by so much our JV can't catch up. Yeah. Or they gave you a graphing calculator, so it doesn't really matter that they showed up late because the dominating factor of the date was they gave you a graphing calculator. Yep.
What if on the AP test and it's multiple choice, what if like the first two answers are like 48.997 and then like 49?
They wouldn't do that.
They wouldn't do that?
They can't do that.
Okay.
Because both of them would be correct.
Okay.
Yep. Seth.
If you have something like the previous one where the larger exponent of 1.
Yep.
What would you do then?
They would the answer would probably be does not exist, but be aware it may also be infinity. But does not exist in infinity or saying the same thing in different methods. In other words, it does not get close to anything. Infinity is just telling you it's going positive. Negative infinity would tell you it's going negative. Because when you see infinity, you can't think of a number. You got to think growth without bound. And it's either positive growth without bound or negative growth without bound. Because, you know, you've been in those relationships where you break up and then you just start spinning on the crazy cycle. And, you know, your friends start sharing stuff on Instagram and then her friends start sharing stuff on Instagram. And then it just keeps getting worse and worse and worse. And pretty soon you can't even like park in the same area of the parking lot. Like there's a cop separating you. That's because the relationship's going to negative infinity.
Wow.
Other questions? We've all had it. And then you can't even be friends with like your friends because your friends have to decide which one they're going with. And
Does that happen to you?
what's that?
Does that happen to you? Is that why you're so good at all these
Not really,
things?
but I was in high school. I know it's hard to believe this, but I did go to high school. In fact, kind of ironic. A guy I went to high school with, I have his daughter in class this year, which is really shocked because he has a really unique last name. I was like, hey, do you know this guy? And she's like, oh, yeah, it's my dad. He lives in Minnesota. I was like, no. Darn it, I'm getting old. because I'm like 35. So that means you had to have a kid like almost immediately out of high school. And oof, I just didn't think I was old enough to have that happen. So anyways, yes, I went to high school and I went to Catholic high school. There were literally 35 people in my graduating class and you knew everything about everybody. And when somebody broke up, like hashtag awkward, because you were in all your classes together. Because that unless band, French, Spanish, those were different, but everything else, you took everything together. Yep.
Were you ever friend zone?
Yes. Next.
Were you like Caleb Neal in high school?
No. Actually, if you would have told me I was going to major in math in high school, I'd have been like, oh, no, I'm not. I'd have probably said a 4-letter word.
You like planes?
I did not like planes in high school. In high school, I was really into debate, basketball, and band. Yep.
So you and your wife met in debate. So were you at the same
We didn't
school?
meet in debate. That's what we did together was debate. Because I've known her, like we grew up in the same church, so I've known her since like I was a little baby. She was a little baby. So we debated together in high school, and then started dating. We started dating when I was a freshman in college. She was a senior in high school. Yeah.
That would have been cooler if it like was the other school.
What do you mean?
Head debater.
She actually didn't debate her senior year. I think she only debated her freshman and sophomore year, and then she dropped it because she was more interested in band. And in South Dakota, everything's a giant commitment because if you want to go to anything, like you're either in Rapid City and then you have to go to Sioux Falls. So like for basketball, you have some games in Rapid City, but most of your games are either in Sioux Falls or Sioux Falls teams coming to play you. So it takes your whole weekend. So you really, like you guys say, oh, I can't do anything else, but you could. We really couldn't do anything else because if you were with basketball in Sioux Falls, you can't do debate in Rapid City. So South Dakota, you really can only do one thing. More people do than I wish did. I think I probably have the most babysitting on the bus to do out of any coach that works here. Yeah, last year our team like fell in love. It was gross. Okay, other questions on that?
You can plug in for it. Like,
Not all of them, but we had a solid 4 couples at one point because we took a bus to Denver Public School of the Arts, which was a revealing trip for us in many ways. And
Was it like a orgy?
no, they have statues there that your parents would never let you have here. Like there was anatomy lessons going on in the hallways because their statues were like rated not R. In fact, one of my parents said, "Can they cover that up?" And I said, "I don't think they cover up much." And I was like, "Please don't let her go in the art room because there was a lot of detail work there. It was very informational." We're never going to that tournament again. It was who's in debate here? Nobody's in debate, but it was. Did you go to that tournament?
Yeah, it was fun.
It was chaotic. They ran out of awards. So they just started giving out what? Do you remember?
Little tiny thing.
No, they gave out hugs. So like Jacob Tunna won his event and he didn't get an award. He got a hug from Denver Public School of the Arts, from their coach. Okay, let's talk about some more. Oh, what should we go for here? We already talked about that. We already talked about that. Yay, let's talk about some other limits. Because you can kind of feel like we're wrapping up this chapter, heading for the home stretch of it. Thank you. Other limits. Let's talk about the limit as x goes to infinity of e to the x. Well, we've got e, that's like 2.718. We're raising it to a very large power. So in other words, we're multiplying 2 by itself a very large number of times. That's probably doing what?
Infinity.
Going to infinity. Notice I put the equal sign in there because it is in your book. I really hate that though, but I do. What about if it went to negative infinity?
No, it would still be in zero. I don't know.
Yeah,
Is it
Noah.
odd or even?
What'd you say? Why? Right. This is really like looking at 1 over e to the x as x goes to infinity, because what's that negative power going to do? It's just going to throw it in the denominator. And if you've got e to a really large power in the denominator, what's that going to make it really get close to? 0, right. It's going to make it really get close to 0. Let's talk about the natural log. The natural log also goes to infinity. If you remember what the graph of natural log looks like, notice it can't go to negative infinity. But as x goes to infinity, natural log of x goes to infinity. What else did I need to cover from that? Covered that, covered that, covered that. Then the blanket statement that all limit properties. So remember, 1.2 is just a giant list of things you could do with limits. Like you break them up by addition, you could break them up by multiplication, you could bring the exponent out in front. All limit properties apply to the limit as x goes to infinity as well. Now, I did ask you to be careful that if the limit of something is going to 0, that doesn't necessarily imply that you can use like 0 times that. Like 0 times infinity. So I'll say that. Cautions. I did that last class too. Some cautions. 0 times infinity is equal to what?
0.
No.
Infinity.
Sometimes.
Sometimes.
When you see that, you got to start thinking the word, that depends. Infinity times infinity, yeah, that's equal to infinity. Or I should say goes to infinity. Infinity divided by infinity, depends. Depends on how fast the top's going to infinity. Depends on how fast the bottom's going to go to infinity. These are all called something called indeterminate forms. Indeterminate forms, and what that means is we just really can't determine it without learning more calculus. 0 times infinity is not 0. Be careful, especially because it's the limit. Remember how I asked you, did it actually get to 0? No, it didn't actually get to 0. It just got infinitely close to 0. What does that mean? It never actually gets there. So you can't take something infinitely close to 0 times something and assume that the answer is going to be 0. It depends. But that's the good news of calculus. We find ways to determine what happens when it depends. Yep.
So is that indeterminate forms kind of a sneak around way of saying they teaches that right now?
Yeah. But I'm telling you in the homework, don't just look at that and say, oh, yeah, infinity by infinity, that's equal to 1. Yay. No, it depends on how fast the top's going to infinity and how fast the bottom is. X squared is going so much faster than x that it depends on when the x squared is. X to the 16th is going so insanely faster than x that it depends on where the x to the 16th is. Brittany, for right now, you'd put, we don't know. Right.
We're learning that next
Yep.
year.
So with the infinity times infinity, have you
Yep.
heard of the infinite hotel theorem?
Yes.
Wait,
What is
okay.
your, what are your
Yeah, you
thoughts
get
on that?
We'll talk about that later. Because we'll learn some stuff in this class that'll help us out with that. All right, anything else? Covered that, covered that, covered that. Yay, let's talk about horizontal asymptotes. Or no, vertical asymptotes first, then we'll talk about horizontal. Vertical asymptotes, back from the glory days of pre-calc, we gave the definition. That's what you can't plug in for x. Not very rigorous. We're going to give a more rigorous definition. First off, though, what's a vertical asymptote looks like? It is a not removable discontinuity. Non-removable discontinuity. Bless you.
Isn't this the denominator?
Yeah, this is. So like if we have, I don't know, like x over f of x. Over x minus 2. Oh, yeah, I know. Your Algebra 1 class, you thought you could just cancel out those x's, but it turns out you can't, which made math hard, which made everything complicated. Forgot to put an equal sign in there. Okay, where are we going to run into trouble? If we plug in x equals 2, we're going to do what? It's going to be undefined. But let's look at what happens as we get close to 2. And then let's think about our rigorous definition that we could have of vertical asymptotes. So we plug in our old friend x over x minus 2, x divided by parentheses x is a plus 2 or minus 2, minus 2. Zoom standard, there we go. Beautiful looking train wreck, beautiful looking. All right, now look at what happens at x equals 2. Let's use some, it is a what at x equals 2? Vertical asymptote. Now what happens at x equals 2 using this calculus stuff we've talked about that could make it happen? What is our calculus words now we could make it happen?
As the left side gets arbitrarily
As the
close.
what of the left side? Limit of the left side as x approaches 2 from the left is either equal to what? Negative or positive infinity. From the right, what's it also equal to? Negative or positive infinity. Okay, so now we get a more, okay, so x equals to trouble. Yeah, you know, touche. Fair enough, touche on that one. Okay, so here's our definition. A vertical asymptote, very rigorous. We've waited our entire life for something that's good. The line x equals c is a vertical asymptote of f of x if any of the following are true. Oh, I got a plethora of paper. I always make mistakes, so I got lots of this. If any of the following are true, the line x equals c is a vertical asymptote of f of x if any of the following are true. The limit from the left as x approaches c from the left of f of x is equal to infinity. And I'm going to be lazy and put plus or minus infinity. And really, I hate that equal sign, but yet it is in your book, so I'll use it. Or the limit as x approaches c from the right of f of x is equal to plus or minus infinity. So really what did it do? It gave us a more rigorous definition of what we were talking about. More rigorous. Okay, so note, and I also like to give cautions. Cautions, note, this is not a removable discontinuity. Because a removable discontinuity, you can do what with the algebra? You can remove it. You can cancel it out. AKA, algebra lets you cancel it out. A removable discontinuity is just undefined at that one point, but the limits are equal. It's like we're going to there, we hit the spot and there's an open dot, and then it doesn't work just at that one point. This is one where it's going to be going to either negative infinity or positive infinity as we get close. In other words, it's growing without bound or it's decaying without bound. Now, as every teacher ever, I always hope that somebody investigated with you. You know, if you've got x minus 2 and you're plugging in values that are really close to 2, those are getting really, really small. And if you have something over something that's getting really, really small, that's going to what? You know.
Oh, infinity.
Right. If you're dividing by 0.1, 0.01, 0.001, so now there's not, you got one pizza and there's 1/100th of or there's 1/100th in each slice, you get a lot of slices. And if it goes to 1/1000th, 1/10,000th, one pizza gets you 10,000 slices if you cut it into 1/10,000th of a pizza. So that's why it's growing without bound. As the top is going somewhere and the bottom is getting unbelievably close to zero. In other words, the amount of pizza in each slice is getting really tiny. Yeah, you buy one pizza, you get 20 million slices out of it. It takes a long time to cut, but man, you fed the masses. Not much, but you fed them. You're flying to Africa with one pizza, one microwave. I don't know if they'd be really receptive to that. Yeah. All right.
What's that last word?
Cancels it out. I know. I kind of budget cutted that into one word. It out. Yep. Okay. So here we go. I will give you questions like what's in your homework for tonight, and then that'll be it for today. Just so you know, test on Friday. All we have left to cover is horizontal asymptotes, and that'll take about as long as vertical asymptotes does. Then I will literally open it up to you on things you want to talk about. Now, do I give reviews? No, I do not. You will get this natural log of 1 reviews this year. I believe if you're in an extra credit class, honors, AP, how do you earn that extra credit? You don't get reviews. Now, here's the deal. If you don't know what's on the test, you're in trouble. So you should be able to go back through your daily quizzes, go back and see what I thought was important and go through. Now, I realize for a lot of you, you've had my test before and you know what it's going to be like. But for some of you, this is a new experience. So it's like dating. You know, first date, you got to kind of figure out what things are like. So I'm aware that, you know, the first test can be some shock and awe. I will let you know, this is probably the hardest test of this semester. Probably is. What's that? Comparable. Now, here's the deal with that. That's just because of the topic. Like limits are the least definite topic we talk about this semester because then we get into really concrete things. Like you will be able to write the test after this. So let's take a look at an example. Example number 3. Did you really think I was going to let you out 4 minutes early? No. Come on, people. Your parents pay taxes for a reason. F of x. Oh, hold on. X. Okay, here's what I want you to do. Find all of the vertical asymptotes. Now, you may say, oh, I plug in 3, I don't get an answer. No. We give a much more rigorous definition. So in other words, if you think 7 is a vertical asymptote, you better say the limit as x approaches 7 from the left is equal to this. The limit as x approaches 7 from the right is equal to that. Hashtag rigorous vocabulary. Find all the vertical asymptotes. Find all the vertical asymptotes.
It's right, like,
Jordan, I thought I saw yours or Griffin's hand up. Question. There will be a calculator and a no calculator section, just like the AP test. So and again, there are only 2 kinds of questions you're going to face all year. Ones you have to use your calculator on. If you can, and I know we haven't really used the calculator for a lot of calc stuff yet. We will. If you can use your calculator, you do use your calculator. Now, here's the bad news. I can't make this fair. If you don't have a CXCAS, it's just like the AP test. You're going to be able to put limits in, your friends aren't going to be able to. Now, here's the good news. There's not very many questions that the CXCAS gives a strategic advantage over people that don't have it. In Calc 2, there are. I mean, if you're in my next class, I bet you all but 2 people have the calculator. Why? Because it is a huge advantage on that test. And that's why I said, if this is your last math class, it's probably not worth it. Because limits you can do, but everything else you can pretty much do on your calculator. It's just a little bit more like effort you have to put in. No.
So if we look back at all the quizzes you've given us so far, you say we're pretty prepared.
Yep. And I definitely look at those AP questions at the end of the sections. Because I will let you know, virtually your entire test for the entire year are old AP questions. Like, I'm not kidding you. We're going to train for this marathon all year long. So when you look at that AP test, you're going to be like, I've been doing this all year long. Nothing new.
So the test is 1.1 through 1.4?
Yep, 1.5. We're doing 1.5 right now.
Oh.
Yep.
so will there be multiple choice?
There will be multiple choice. There will be free response. There'll be multiple choice, no calculator. There'll be free response. I mean, there's 4 sections: calculator, multiple choice, calculator, free response, no calculator, multiple choice, no calculator, free response. Now, I mean, and I make you show your work on your multiple choice responses, but only like it was a multiple choice. So if you don't show all your work on a multiple choice, I'm fine with it. Now, for those of you that haven't had me before, calc tests are hard to grade. So it takes at least a week for me to get them back to you. Now, this class is pretty small, so I might be able to turn it around a little bit quicker, but I will literally grade everything you write on that sheet of paper for its correctness. So do not write anything that's incorrect, ever. Like Breebach. Even if it had nothing to do with the problem, if it's on there and it's not right, it's wrong. Schneibel, I know. Because other classes you have for me, I just look for correctness. This one, I got to prepare you to speak a really good language account. All right, where are the vertical asymptotes? 3, -3. And that, what are you going to do to define that? Because the limit as x approaches 3 from the is equal to something. The limit as x approaches 3 from the left is equal to something. Have a good day. I'll text out the homework in just a minute. We did get a little bit farther than the other class, so you are going to have a little bit more homework than they did, but it'll be the same assignment at the end. But I probably won't text it out until 4th period today.
Lunch, senor. Devontae. No, wait, no. Here comes Devontae. No. Tishana.
I was like,
Sharquisha.
It's an insanely black name. Sharquisha. You're gonna have stuff in your bag. Ew. Disgusting.
Check it out.
see you tomorrow, Beckman.
See ya. Scheibel. Where'd she go?
LeBron.
There.
Really cool infinite product. Converges to I.
This morning.
Yeah, I do.
I'm not gonna be here on Friday because we're going to a wedding in Michigan.
I'm sorry.
I know. I get to fly there, so I'm fine with it.
Oh, you
What
can fly
airline?
where?
United.
I'm sorry.
Or Frontier.
On
Oh,
what?
that's better.
Wait, United on
Okay, it's better than United.
what? On what? I've never actually.
I've never seen